Hi everybody, the purpose of this video is to go over section 5 of chapter 2, and we will be talking about solving linear equations of the form ax plus b is equal to cx plus d, where x is the variable of interest and a, b, c, and d represent numbers. In this video we will talk about how to solve those equations, and we will also talk about the terms conditional equations, identities, and contradictions. Conditional equations are those equations that are true for certain values of x and false for all other values of x. Identities are equations that are true for all values of x, and those are used a lot or come in handy when we study the ideas behind trigonometry. And contradictions are equations that are false regardless of the value of x, and although that sounds a little peculiar, it turns out that the idea of the contradiction is a very useful proofing technique. But we want to talk about solving equations of the form ax plus b is equal to cx plus d first. And just like any other equation, the goal is always the same. We want to isolate x. We want x on one side of the equation, doesn't matter which side, just one side of the equation, and everything else on the other side of the equation. And how do we do that? Well, you can do it any way you want, provided that you maintain the equity. And of course, we have a chest of tools that we can use to make that happen. The first one is simplification, or combining like terms. And if you remember, like terms are those terms that have the exact same variable and the exact same exponent. We can use the addition principle of equality to move terms around, to move whole terms around. For example, we can use the addition principle of equality to move ax over here, or we can use the addition principle of equality to move d over here. Once we have done that, we will have an equivalent equation that looks something like this. Some number, I'm going to call it alpha, times x is going to be equal to some other number, I'm going to call that beta. And then we will use the multiplication principle of equality to get rid of this coefficient. What do we do? Well, we'll divide this coefficient, we'll divide this term by alpha to make the coefficient 1. And once again, what you do on one side, got to do on the other side. And then this will cancel, and we will have x will be equal to beta over alpha, whatever beta and alpha happen to be. And the last tool that we have is the distributive property, where if we actually have a number multiplied by a sum of two terms contained in grouping symbols, like b and c, well, that will be equal to a times b plus a times c. We will distribute a with the b and with the c. Just as before, we have a procedure. What is the first procedure? Well, first thing we want to do is we want to simplify, and that will involve combining like terms and sometimes even using the distributive property. Once you've done that, we are going to use the addition principle of equality to move all the terms with an x to one side of the equation and all the terms to the other side of the equation. So by the time we're done, we might have something that looks like, well, once again, beta is equal to alpha times x, where once again, beta and alpha are just numbers. And then third, we will use the principle, the multiplication or division principle of equality to get rid of that coefficient or make that coefficient be equal to 1. And of course, you will do that once again by dividing this side by alpha and then also this side by alpha to preserve the equality. And then once we're done, we will check to make sure that we are actually indeed correct. Okay, so let's go ahead and do that. Here is our first example. Here we want to solve this equation. 4x plus 1 minus x is equal to 2x plus 13 plus 5. And the very first thing that we're going to want to do is simplify. And here we can simplify by combining like terms. Notice here we have a 4x and an x. Those are like terms. Here we have a negative 13 and a 5, and the absence of a variable makes those like terms as well. So combining, we will have 4x minus x, which is 3x, plus 1, and that will be equal to 2x, minus 13 plus 5, which is minus 8. Okay, once you've done that, we now want to use the addition principle of equality to move terms around. Specifically, we want all the terms with an x on one side of the equation and everything else on the other side of the equation. Now, what I'm going to do is, in this particular case, I'm going to want to move this term over here, and I will do that by subtracting that amount from this side. And to maintain the equality, I'm going to subtract the exact same thing over here. Okay, since I want all the x's over here, I want all the constant stuff over here. Or since I have all the x's on the left side, I want all the constant terms on the right side, which means I want the 1 over to the right side, and I can do that by subtracting 1 here, because 1 minus 1 is 0. If I'm subtracting 1 on this side of the equation, I have to subtract 1 on the other side of the equation. And now we can do all these operations vertically. 3x minus 2x, well, that's just x. 1 minus 1, they cancel. 2x minus 2x, they cancel. Negative 8 minus 1 is negative 9. Okay, and now we have to deal with the multiplication property of equality, because we want the coefficient next to the x to be equal to 1. But hey, check it out. It is equal to 1, so we don't need to do anything. Here we will have x is equal to negative 9. So finally, we just need to check. What we're going to do is we're going to take the negative 9 and substitute it into the x here, here, and here. So let's go ahead and do that. We will have 4 times negative 9 plus 1 minus a negative 9. That's going to be equal to 2 times negative 9 minus 13 plus 5. Okay, well, 4 times negative 9 is negative 36. Plus 1, and then a negative minus negative 9 is simply just plus 9. And then over here we have 2 times negative 9, which is negative 18. And then minus 13 plus 5, that is negative 8. Okay, so now, negative 36 plus 1 plus 9, that is basically negative 36 plus 10, or negative 26. And you've guessed it, negative 18 minus 8 is negative 26. So it checks out, and this is correct. Okay, here is our next example, and this equation has the dreaded fraction. So we want to simplify. And part of our simplification process is going to be to get rid of the fractions. And we can do that by multiplying the entire equation by the lowest common multiple of the denominators, which in this case is 3, 6, 5, and 10. In this particular case, that is the lowest number, the smallest number that has all of those values as a factor. And that number would be 30. Why? Well, 30 is equal to 3 times 10. So 3 and 10 are factors, and 30 is equal to 5 times 6. So 5 and 6 are factors. So we want to multiply this side of the equation by 30, and then to maintain the equality, we want to multiply this side of the equation by 30. And if we do, we will have 30 times 1/3 times x plus, using the distributive property, 30 times 1/6. And that will be equal to 30 times 5/2 x minus 30 times 7/10. Okay, now 30 times 1 is 30, divided by 3 is 10, so we have 10x here. 30 times 1 is, well, 30 divided by 6 is 5. And I have a mistake. I inverted some numbers here. Let me see if I can fix that. This should not be 5/2, this should be 2/5. There we go, much better. 30 times 2/5, 5. 30 times 2 is 60, divided by 5 is 12. So over here we have 12x. And then 30 times 7 is 210, divided by 10 is 21. So this will be minus 21. So now we have it simplified. And now we want to use the addition property of equality to get all the terms of the x's on one side of the equation and everything else on the other side of the equation. Now we probably also want to do this so that the coefficient happens to be positive. So the coefficient associated with the x happens to be positive. That way we don't need to deal with dividing negative numbers and deal with any sign issues. So with that in mind, since 10x is less than 12x, we probably want to move the 10x over here. And we can do that by subtracting 10x from this side. And then to maintain the equality, I need to subtract 10x here. And then, since we have all the x terms over here, we want the constant terms to be over here, which involves moving the negative 21 over there. And we can do that by adding 21 on the right-hand side. And if we're going to add 21 on the right-hand side, we've got to do the exact same thing on the left-hand side. And now we can add these vertically. Negative 10x plus 10x, they cancel out. That's 0. 5 plus 21 is 26. That's going to be equal to 12x minus 10x, which is 2x. And then these will cancel as well. So notice that we have a positive coefficient. That makes that will minimize the risk of any sign-related errors. And now we need to multiply. Remember, we want to make this coefficient be equal to 1. That way x is by itself, and we can do that by dividing this side by 2. 2 divided by 2 is 1. Once again, what would you do on one side? Got to do on the other side. So we're going to divide both sides by 2. And when we do, we will have 26 divided by 2, which is 13. And then over here, we have 2 divided by 2, which is 1, which is equal to x. And we have that x is equal to 13. And now we need to check. Basically, we want to take 13, substitute it in here, and also in here, and see if the equality holds. Now you can do that analytically, but it might be easier if you just went ahead and do that using a calculator. So let's go ahead and try that. Here is my computer emulation of a TI-84 series calculator, and I would encourage you to buy such a calculator if you do not have one already. It will serve you well in all the math courses that you might find yourself taking here, particularly if you're taking 116 down the road. So what I'm going to do is I'm going to compute this side of the equation with x being equal to 13. I'm going to get a value, and I'm going to compute the other side of the equation with x equals 13. I'm going to see if they're the same. And here's how we can do this. Over here we have 1/3 x plus 1/6 where x is equal to 13. So I'm going to do 1/3 times 13 plus 1/6. That's my answer. Okay? Let's go to the other side. That is going to be 2 divided by 5. 2 divided by 5 times x, which is 13, minus 7 divided by 10. So since we got the exact same result for both sides of the equation, this checks out, and x is indeed 13. In example 3, we have an equation with grouping symbols. Nevertheless, the objective is still the same. We want to isolate x on one side of the equation, doesn't matter which one, and the procedure is still the same. We still want to simplify. However, in this case, we are going to need to use the distributive property to simplify. So what is step 1? Step 1 is to simplify. And we're going to do that by using the distributive property here and here. And once you've done that, we are going to combine like terms. Okay, so let's distribute. To do that, we're going to multiply -2 by this term inside the grouping symbol, and then by this term inside the grouping symbol. So that will be -2 times 5x, which is -10x, plus -2 times 13, which will be -26, minus 2, equals. Now, once again, we have the distribute here. -6 times 3x, that will be -18x. And then -6 times negative 2 will be positive 12 minus 41. Okay, now we need to combine like terms. Here we have like terms, and here we have like terms. So we can combine those, and if we do, we will have 10x, negative 10x, forget that negative. Negative 26 minus 2 is going to be minus 28. And that's going to be equal to negative 18x minus 29. 12 minus 41 will give us a negative 29. And now we want to use the addition property to get all the terms with an x in it on one side and everything else on the other side. Now remember, we want to do this in such a way that we actually have a positive coefficient, so we don't have to deal with that. That will minimize our potential for errors associated with sign units. And that basically means you want to move the smaller term. In this case, the smaller term is negative 18x. So that's the one that we want to move. And we can do that by adding 18x to this side, to the right-hand side. That will cancel that out. And once again, we have to do the exact same thing to the other side. So plus 18x. And if we're moving the x terms to the left-hand side, we want to move the constant terms to the right-hand side. We can do that by adding 28 here, and then adding 28 here. Okay, now doing the addition, we have negative 10 plus 18. That is 8x. 28 minus 28, they cancel. That's going to be equal to 18x minus 18x. They cancel. And then negative 29 plus 28 is going to be equal to negative 1. Now we want to use the multiplication principle of equality to make this coefficient 1. And we can do that by dividing this side by 8. Once again, what you do on one side, you got to do on the other side. So we're going to divide both sides by 8. And then when we simplify these cancel, we have x, and then x is going to be equal to negative 1/8. All right, now we need to check. And we're going to do that by substituting negative 1/8 in for x there, and then for x there, well, everywhere you see x. Now, doing that on paper might be a rather daunting approach, so it might be better if we actually use a calculator. And here is our calculator. So let's go ahead and do the left-hand side with x being equal to negative 1/8. Now, how can we do that? On a T out of E4 series, we'll go as follows. Negative 2 times parenthesis 5 times negative 1/8. Negative 1 divided by 8. There you go. Plus 13. Okay, close the parenthesis. Minus 2. And we get negative 26.75. Okay, let's take a look at the other side. For the other side, we're going to do negative 6 times parenthesis 3 times negative 1/8, negative 1 divided by 8 minus 2. Remember, this is the negative for the negative numbers, and that is subtraction. Close the parenthesis, minus 41. Okay, so the left-hand side gives us negative 26 3/4. The right-hand side gives us negative 26 3/4. So this indeed checks out, which is exactly what we're looking for. I now want to talk to you about the three types of equations that might occur in any mathematical situation. The first one is the conditional linear equation, or the conditional equation. For example, here we have 3x is equal to 6. I bet you guys know what the solution is. You're right. The solution is x is equal to 2. As a matter of fact, that statement is true only when x is equal to 2. And it is false for every other real number. So we say that this is a conditional equation. This equation is true based upon the condition that x is equal to 2. If x is any other number, it is false, and that's the idea behind a conditional equation. The next type of equation is called an identity. For example, consider this equation right here. 4x plus 10 is equal to 2 times the quantity 2x plus 5. It's kind of the statement of the painfully obvious. As a matter of fact, if you went and tried to solve this for x, what you would have is, well, we would simplify using the distributive property. We would have, not that, 4x plus 10 is equal to, well, 2 times 2x is 4x, plus 2 times 5 is 10. If we actually tried to use the mathematical principle of equality to solve for x, well, I would subtract 4x over here, subtract 10 over here, I would subtract 4x over here, subtract 10 over here, and I would have that 0 is equal to 0. And if that's what you get, you have an identity. And what does that tell you? That tells you that this statement is true regardless of the value of x. This equation is true for all real numbers. Therefore, we call it an identity. And then finally, we have contradictions. And here's a contradiction right here. Let's suppose we tried to solve that. Okay, well, the very first thing that we might want to do is try to move all the terms with an x in it to one side of the equation. So using the addition property, I will subtract 4x. If I'm going to subtract 4x there, I'm going to subtract 4x here. And then when I do the operation, these cancel, and I have 10, and over here these cancel, and I have 11. I have 10 is equal to 11. Is 10 equal to 11? No, this is false. Regardless the value of x, this will never ever be true. Therefore, it is called a contradiction. The solution set for this equation is the empty set. In other words, absolutely nothing. And once again, although this seems like a silly thing to do, this turns out to be a very powerful proofing technique, because if you hypothesize a certain situation and you evaluate it and it turns out to be something that turns out to be completely false, that means that the opposite of that hypothesis is true, which is a technique we use to prove a lot of concepts. Okay, we have two examples and then we are done. Here is our first example. What we want to do, you're going to have two equations, and we want to determine if the equation is a conditional equation, an identity, or a contradiction. Once again, we want to determine if the equation is a conditional equation, an identity, or a contradiction. And how do we do that? Well, we start off with the equation and we try to solve it and we see what happens. Okay, so here is our first equation. This is in the form ax plus b is equal to c. We know how to do that, so there's nothing to simplify. So we're going to use addition to get the constant term over here. We're going to subtract 16 from this side, and if we're going to subtract 16 here, we are going to subtract 16 here to maintain the equality. And if we do, these cancel, we will have 3x is equal to negative 27. And then using the multiplication principle of equality, we will divide this side by 3 and the other side by 3. These will cancel. This will become negative 9. And we have that x is equal to negative 9. So this is a conditional equation. And in your homework, if you determine that an equation is conditional, you will also need to write down what the solution set is. And the solution set is negative 9. Okay, for our last example, we have this. And we want to determine if this is, once again, the conditional equation, an identity, or a contradiction. And we figure it out the exact same way. We solve for x. Now notice this time, we need to simplify. First, using the distributive property, and then combining like terms. So using the distributive property, we have 3x minus 3 times 25, which is 75, plus 3x. And then over here, we have 6x. 6 times x is 6x. 6 times 10 is 60. Okay, now we can combine like terms. I have a like term here and a like term there. That's going to be, and those can be combined to 6x. And we have 6x minus 75 is equal to 6x plus 60. And at this point, you can probably determine what kind of equation this is. So you can look at it and go, this is definitely a contradiction. But taking it one step forward, we're going to use the addition property. Try to get all the x terms to one side. And we will do that by subtracting 6x here. And if I'm subtracting 6x here, I need to subtract 6x here. And doing the operation, these cancel. I have negative 75. And over here, these cancel, and I'm left with 60. So I have that negative 75 is equal to 60, which we know is false, regardless of the value of x, because x is no longer a term in the equation. So regardless of the value of x, this statement will always be false. So we have a contradiction. And that also means that the solution set is the empty set. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Oil, signing off.